Good night, good night, good night. We're about to start. Just waiting a few more minutes. See if anybody else will join us. All right, guys. Good night again. Thank you all for joining. And in tonight's episode, we're going to go on to page 78. And we're looking at the exercise there. And we're going to do only 4 items this evening. All right. So page 78. And we're looking at those 4 items there. The first one says, there are 60 children sitting in 3 classrooms. 60 children sitting in 3 classrooms. So, suddenly, 5 boys left the first classroom, 7 girls left the second classroom, and 6 children left the third classroom. Then there were the same number of children in each classroom. How many students were in the second classroom at the beginning? Now, there's a whole lot of information here to process. So let's see if we can set out this a little bit so that we can get it. Let me see if I can get a circle going here. Just give me a second. Let's see if we can get this circle. Okay, hopefully we'll get this going. Okay, great. So I have my mouse highlighted now. So let's put 3 circles, 1, 2, and 3 to represent the 3 classrooms that we're talking about. All right. And we know that in all, when we add the number of students in all these 3 classrooms, we're supposed to get 60 students. Okay. So from the first classroom, it said that 5 of them left the first classroom, 5 boys. Then 7 girls left this classroom. Then afterwards, 6 students left the third classroom. Let's see if I can get this off the screen here. Let's go, let's go, let's go. Okay. All right. Okay, great. So again, we have 3 classrooms, 5 left the first one, 7 left the second, and 6 left the third. Then after that, there were the same amount of students in each classroom. So let me see now. If it is that I have 5 and 7 and 6, how many students left to begin with? All right. 5 and 7 would be 12, and 12 and 6, that would be 18 students. All right. So if I add all of these, then I would have 18 here. So 60, if I have 60 and I take out 18, this would be 5, and we put the 1 here. So 8 from 10, let me make this one a little better. 8 from 10 would leave me with 2, and 1 from 5 would leave me with 4. So there will be 42 students left after the 18 students here came out. Okay. Now they said that the 42 students that were left, each class had the same amount. So that would mean we have 42 and we divide this by 3, and 3 into itself 1 time, 3 into 4 would go 1, and we have 1 left over, and 3 into the 12 would be 4. So it means that there would have been 14. Let me swap colors here. Let's make that a purple. We have 14 students here in each class. Okay. So again, remember what it said now. It says there were 60 students in 3 classrooms. Suddenly, 5 boys left. So here we have the 5 that left. Then the 7 girls left the second classroom, and 6 students left the third classroom. So we have all of that. A total of 18 students left. So 18 from the 60, 42. Cool. So 42 students would have been left. Then there were the same amount in each class. So take that 42, divide it by 3, so you'd have 14 per class. So it says how many students were in the second class at the beginning. So if I have 14 left and there were 7 there before, all I would need to do is put the 7 and the 14 together, and this would give me 21. All right, I'm not going to stop there, because I'm going to say the 5 and the 14 here, this would be 19 that were in the first class at the beginning, and 6 and 14, that would make 20 at the beginning. Now I need to check if this is true. So I'm going to add the 19, the 21, and the 20 and see if I get back 60. And if I get back 60, then I know that my calculation is correct. So I'm going to just put this here, 20, 21, and 19. We're going to add these all together. So 9 and 1 would be 10. I'm going to write 0 and I'm going to carry 1. And then I have 1 and 2 being 3, 3 and 2 being 5, 5 and 1 being 6. So after all is said and done, I get back the 60, right? So then I know that these would be correct. Now, which one did they ask for again? They asked us for the second classroom. So our answer would be 21. Put that in a nice box. And we say answer is equal to 21. All right, so we can do it like this as well. And if we have it on our page like that, the examiner has no need to wonder what our answer is. All right, because we have a lot of calculations on the page, but we need to point out to the person marking what exactly is the answer. Our answer is 21. Any questions? Any comments? I'll wait a second or two. All right. I see no comments online. Okay, great. And I have someone here saying, no, sir. I'm going to show this comment. This person has a very interesting name, Toxic Killer, right? But whoever this Toxic Killer is, they are watching and they are commenting, and we want to, say how important that is that one is participating. All right, cool. So we're moving on now to the second question. It says, Anne Marie chose a certain number. She subtracted 104 from it and then added 1004 to her answer. The final result was 10,004. What number did Anne Marie choose at the beginning? Now, as with any worded problem, one has to really read carefully and set out based on the information that has been given. So you can't read this in an exam situation. You could never try to read this one time and then start working. Okay, so let's go with this now. So Anne Marie chose a number. Do we know that number? No, we don't know the number. She subtracted 104 from it, and then she added 1004 to her answer. The result was 10,004. What number did Anne Marie choose at the beginning? All right, so this is how I would set this out. I would start off by saying the number that I don't know is represented by this box. We know that she subtracted 104 from the number, and then she added to that number 1004, right? And in the end, her answer would have been 10,004. Yeah, that's it, As simple as it is. That's what the question is saying. So let's say that we wanted to find out what this is. If I wanted to get the box by itself, I'm going to first take away this. And when we were in grade 3, we would have heard that we're going to take this one, take it over the equal sign. And when it goes over the equal sign, it will change the sign. So this will change from a plus to a minus. That's the principle we're working with. All right. So we would have now here 10,004. Okay, so 10,004, and we're going to take away 1,000, right, and 4, and then now we're going to add to that number, whatever that is, we're going to add to that 104. So let's go. So 10,004, and we're going to take 1,004 from this. So 4001. When we take this away, 4 from 4000, and 1 from the 10 here would be 9,000. Right? So we have 9,000. Then we would add this 104 to that. So that's 104, and we're going to add this. So we would have 4019. So we're looking at the original number being 9,104, right? So let's test this now to see if it is correct. So remember our original statement here. We're going to test this to see if it's correct. So we're going to swap colors, and we're going to say 9,104. And if that is so, if we take off 104 from that, so 9,104, we're going to first subtract 104. So here we have 104. We subtract that, we're going to get 0,009. So we have 9,000. Then we are going to add to that 1,004. So we're going to add 1,004. Let's get another color here. Let's go green. So we're going to add 1,004. Add this, and we get 400 and then 10. So we have 10,004. So this shows the process that we use to go back and then to check our work, because over here what we're doing, we would be what? Checking our work. So we check to make sure that we get back the original number that they told us. All right. So we have a number. We don't know what the number is. First, we took 104 from that number. Then we added 1,004. And at the end, we had 10,004. How did we solve it? We said, okay, if we wanted to find what this number, the unknown, is, I am going to first, I took away the 1,004, and that's this section here, did this part first, and then I got 9,000. Then I would add, because remember I'm going over the equal sign, so I'm going to do the opposite. I'm going to change the sign. So I would add the 104 to the 9,000, getting 9,104. So to prove if that is so, I'm going to check my work by plugging this in where this is. So this now represents the unknown. So now we know it. And then I'm going to take from that the 104. When I take that away, I get back to the 9,000. So I'm, in one of the videos that we were watching in early class, they said that addition and subtraction is like tying your shoelace, and then the opposite of that is what? Untying the shoelace, right? So here we were going in a particular order, and you see we are reversing that particular order here. And then after we add the 1,004, and we get 10,004 here, which they told us. So we now know that our answer is 9,104. Again, I like when you write answer equal 9,104. Okay, put that in a nice little box. So when the examiner is looking at the paper, there's no question as to what the answer is. All right. Any questions on this one? Okay, we don't see any questions coming in. All right, so we move on to the next item. So item 3. If we go to item 3, let me get a nice fresh page. Item 3 says the answer to a mathematical question was 10.5. And we were doing some decimal work earlier today. So 10.5 is the answer. So let me put this down here. Let's get blue. We say 10.5. Okay. So the answer is 10.5. What else does it say? It says here Ruth had 1.05. So that's not 10.5, no, that's different. It says no, what, by how much was her answer too small? And I can subtract to find what that difference is. So she had 1.05. So we'll line this up as best as we can, column by column, digit by digit, decimal point under decimal point. So the first thing I'm going to do, I'm going to put in a placeholder here. And this placeholder is especially important when we are subtracting. So let's go now, and we're going to say 5 from 0. That can't work. If we didn't put the placeholder, a lot of people would be tempted just to write back 5, and that would not make our answer correct. So we're going to take 1 from this 5, leaving us with 4 here. Then I'm going to put that 1 there. This now is functionally 10. We're going to say 5 from 10 would leave us with 5, because 5 and 5 makes 10. I have nothing here to take from the 4, so I'm going to bring this 4 back. I'm going to make sure I have decimal point under decimal point. And I am going to say 1 from the 10 that I have there. This will leave me with 9. I have the wrong sign here. I have an addition sign, but we shouldn't have an addition sign, because we're going to find the difference. We need to do what? We need to subtract. All right, so let's make sure that we have our operation sign correct. That's important as well for exam purposes. So we have 9.45 being the answer. So again, yes, that's good. And I see our answer coming here on screen. So here, Toxic is saying that the answer is 9.45, right? Great. So clearly Toxic knows what is to be done when lining up these digits and following through with the subtraction to make sure that we get the correct answer. All right, so we have one more to go, and this is question 4. All right, so let's get a nice fresh page again. This time around, it says, the light in a lighthouse flashes every 10 seconds. How many times does it flash in 1 hour? So the light in a lighthouse flashes every 10 seconds. How many times does it flash in 1 hour? So let's go with this. We need, first of all, to find out, we need to set this out so we have a good representation of what is happening. And this is what I would do. I would write on this side flash and time. Okay, flash and time. So we have 1 flash every 10 seconds. Then we want to find out how many flashes, an unknown amount of flashes in 1 hour. Okay, but this time was in seconds. Now earlier today we did something. We did a question that was a follow from the last presentation that we did last evening, where we said that we need to make sure that the units are the same. So I need to now convert my hour into what? Seconds, so that I can be true to this particular setup. So 1 hour is made up of 60 minutes, and 60 minutes, each minute is made up of 60 seconds. So I multiply that and I will get the number of seconds in an hour. So I'm going to put 0 as my placeholder here for this one and move on to this 6. 6 times 0 is 0, and 6 would be 36. So there should be 3,600 seconds in an hour. All right, so I'm going to Instead of having the hour here, we could have 3,600 seconds. Okay, so we'd have 10 seconds and 3,600 seconds. All right, so this represents the hour in seconds. All right, so we bracket this off so we know what we're doing. Now, in order to continue, I can simply try cross multiplying. Hold on, let's get back. Yes, can cross multiply here, here. Now on this side, I'm going to have 10x, and this would be equal to 3,600 seconds. On this side, 3,600. I'm not writing the seconds just yet. And that what I want to do now is to get x by itself. Now x is being multiplied by 10. To the opposite of that, which is to divide this side by 10. If I divide this side by 10, I will also have to divide this side by 10. So 10 on this side. Now 10 will cancel 10 here, leaving me with x by itself. That's what I wanted. And now 3,600 divided by 10. 10 into 10, 1. And 10 here will cancel off this one. So my answer here will be 360. All right, so let me make that neater. 360. So I write 360 here. So what this is saying is that in 1 hour, this light will flash 360 times. All right. So again, let's go with this. The light in a lighthouse flashes every 10 seconds. How many times does it flash in 1 hour? And the answer is 360. So if we wanted to make that neater, we could say answer equal light will flash 360 times in 1 hour. Okay, and of course we put a nice little box around this so the examiner knows exactly what the answer is. All right, that's the end of our little session for this evening. I hope that you were able to follow along and take the opportunity to move on to items 5 to 8 on the other side, so that when we get to class tomorrow, we can just quickly go through and finish up with this part of our unit. All right, guys, thanks for joining, and I will see you in the next episode.